Today we want to look at solution to quadratic equations using the method of symmetry. So what exactly do we mean by the method of symmetry? There is a particular properties. We all know that when we solve quadratic equation, we get two values. The two values are called the root of the quadratic equation. I name one of the root to be alpha and the other root to be what? Beta. So if we plot the quadratic graph of the quadratic equation, we are going to have a graph, a curve that will call the x-axis at 2 points. This is the first point, and this is the second point. It will cut it at 2 points. You can call this one the first point, and also this one the second point. There is no order to that. So there is a property, very, very important property, that says the solution, where the solution is, where you have the two solutions to the quadratic equation, there is a line that passes through their midpoint. That is, the distance between alpha to this line is the same as the distance of beta to this line. That property can be utilized in solving the quadratic equation. We know that when we want to solve using the factorization method, we have to guess two numbers. But in this, using the symmetric solution, we don't need to have any guess at all. It saves us from the stress of having to guess a number, because guessing a number is as difficult as the value of the product. If the value of the product is very, very high, it is very difficult to guess the two value with ease. So using the method of symmetry, you are saved from this stress. Okay, now what do you mean by the method of symmetry? Let me say that again. The method of symmetry simply utilizes the property that whenever we have two solutions to a quadratic equation, there is a line which passes through their midpoint. That is, alpha and beta are equally spaced from this line. The distance of alpha to this line is the same as distance of beta to this same line. Good. So we can write the equation for this line of symmetry. We call this line of symmetry. We can write the equation for this line, and the equation is given as x is equal to minus b over 2a. Good. We are going to need this equation when we want to use this method to solve. Then, if we know this value, then we know going backward, we get the alpha. Stepping behind, we get the alpha. So what does it mean? It means that if I make the gap here to be d, then if I step backward by d, that is x minus d. If I step from the line of symmetry forward, that is positive side, that is x plus d. So moving backward is x minus alpha, x minus d, while moving forward is x plus d. So what we need in this method of symmetry are just these three: x equals to minus b over 2a, and these two roots that has been written in terms of d. So let's now see how we apply this method to solve problems. Okay, let's look at this equation. We want to solve this equation: 3x squared minus 5x minus 12 equals to 0. Now, to apply this method, there is a condition. We must make sure that we divide by the coefficient of x squared. Any number that is with x squared, we must use it to divide all through. Because to apply this method, the number that must be with the x squared, that is the coefficient of x squared, must be 1. Must be 1. Positive 1. Okay. Now, the step 1 is to divide through by the coefficient of x squared, which is 3. So we divide through by 3, 3x squared over 3, minus 5 over 3, minus 12 over 3. Then we have this. x squared minus 5 over 3x minus 4 equals to 0. Now, we now locate the line of symmetry using that formula I lay emphasis on the other time, x equals to minus b over 2a. If we are used to the quadratic equation, we will know that whatever that is with x squared, it is called a. Whatever that is with x is called b. So for here, the b is minus 5 over 3. And whatever that doesn't have x with it is called c. Let me say that again. Whatever that is with x squared is called a. Whatever that is with what? X is called b. Whatever that doesn't have x in it, that doesn't have the variable in it, is called what? C. So with that, in our formula now, we have minus b over 2a. Let's go to minus b over 2a. So that will be minus, our b is minus 5 over 3. If you put minus 5 over 3 in bracket here, then divided by 2 times a. That is 2 times 1. So minus, we multiply minus, and we have 5 over 3 here. Then 2 times 1, that is 2. What is with a is 1, don't forget. 2 times 1 is 2. So 5 divided by 3 and divided by 2 again. If we are dividing by 3 and we are dividing by 2, it means that we are dividing 5 by 6. Because 2 times 3 is 6. So we are dividing 5 by 6. So now, we have got where that specific line is. We have got the point at which that line of symmetry, which we want to use to solve the equation, is, which is 5 over 6. So what are we going to do? Then we say 5 over 6 minus d. Stepping backward, we subtract d. Don't forget that. Then we read 5 over 6 plus d. That is stepping forward, we add d. So now, we now realize that in this equation, in every quadratic equation, the equation is generated by this formula, x squared minus sum of roots plus product of roots. What does that mean? It means that this particular thing that I call b here, good. So far this place has coefficient of 1. This particular place I call b here is my sum. It's where we have the sum, where the roots sum up to give this value. At this one, where you have minus 4 here, is where the root multiply to give what? To give minus 4. So what does that mean? It means that if these two are the root of the equations that we have written in terms of d, if we should multiply both of them, that should be product. So it should give us the same value for the product. And the product is what? Minus 4. The product is minus 4. So what does that mean? So that's going to be 5 over 6 minus d. 5 over 6 plus d. They both multiply to give what? Minus 4. If we expand this bracket very well, this is difference of 2 square. Whenever you have something like this, you can say they are the same number, 5 over 6 and d. 5 over 6 then d. The only difference is minus and what? Plus. Whenever you have this kind of stuff, what you just need to do is to square the first one minus, then we square the second one. If you expand the bracket the normal way, that is 5 over 6 times 5 over 6, then 5 over 6 times plus d, then come here minus d times 5 over 6, minus d times what? Minus plus d. You are still going to end up at this one solution. What you have there, you are still going to end up at 25 over 36 minus d squared. So for simplicity, we know that these numbers are only different. The only different thing between them is what? Is the minus and the plus. One has minus, one has what? Plus. So what does that mean? It means that I can square this. That's 25 over 36 minus, I can square d squared. Then it's going to give me what? Minus 4. So I can solve for d square here. Let's solve for d square. So if we solve for d square here, we have 25 over 6. D comes from the other side here, becomes 4. So when you do the fraction, we are going to have 1 over 69, 169 over 36. So I find the square root of both sides. When I find the square root of both sides, good. You know when you are finding square root of both sides, you have to put plus or minus before the number, before you take the square root. So I'm going to have plus or minus 13 over 6. The beauty of this is that we just need a value. You can use ordinary 13 over 6. or we can use minus 13 over 6. Anyone that we use, we end up at the same result. We end up with the same result. Now, knowing the value of d now, don't forget, I already assume the root in terms of d. Let's look at it again. I already assumed the root in terms of d. These are 5 over 6 minus d, 5 over 6 plus d. So immediately I get the value of my d, I just put it in these two equations. Then I get the solution to the quadratic equation. So let's look at this. This is what I got for d, 13 over 6. So that's going to be 5 over 6 plus 13 over 6. That's 18 over 6. That's 3. 5 over 6 minus 13 over 6. You can see I added it here. I got this. I subtracted it here, and I got minus 8 over 6. That's minus 4 over 3. So I now check using my factorization method. And when I check using my factorization method, I end up with the same result. That shows that the method of symmetry works perfectly well. We may look at it that why do we have to use method of symmetry? That it takes a longer steps. No, it is because I have broken this thing down into steps so that you can grasp the concept. So I'm going to solve a question in a very rapid way and see how fast this can be. While some students will still wait and be thinking of two numbers, applying this will give you result with ease. Okay, now let's look at this. What to solve this? Solve x squared plus 6x plus 8 equals to 0. The beauty of this is that x is already having 1 with it here, so there's no need to divide by anything. So we jump to step 1, go to step 2. Step 2 says that minus b, don't forget b is the one that receives x here, divided by 2a, and a is always 1 here. So c is divided by what? 2. That's going to be what? Minus b, that's minus 6 divided by 2, that's minus 3. Later I get minus 3, I'll just add d and subtract d. That's minus 3 plus minus d. Can you see that? Then another bracket, minus 3 plus d equals to the product, 8. Then when I expand this, I get 9 minus d squared equals to 8. If I solve this quickly, I'm going to get my d to be equal to what? Plus or minus 1. I told you, you either pick the plus 1 or you pick the minus 1, anyone. But I love picking the positive. So the roots are going to be minus 3 minus 3 plus, what do you get for d? 1. Minus 3 plus 1, that's minus 2. Minus 3 minus 1, that's minus 4. So our solution is minus 2 and minus 4. You can see in less steps we have obtained the word result. And I hope this is very clear. You can join our page on Facebook, on Instagram, and you can request for classes on or videos on courses or topics that are that you are finding difficult to understand. Will surely help you with solutions, good explanations, and every other thing that can be of help to you. So thank you very much for listening to this.